Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 1. So, to first start, I'm going to rewrite 2 to the power of 25 as 2 to the power of 24 plus 1. And then we have our minus 1 at the end. And the reason I'm doing this, and rewriting 25 as 24 plus 1, is so now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 2 to the power of 24 plus 1 is going to equal 2 to the power of 24 times 2 to the power of 1 minus 1. Now basically our goal throughout this video is to change our values to be as small as possible, so then at the end we can do whatever we need to do with them to get our final result. So 2 to the power of 24, how do we simplify this and make it even smaller? I can rewrite this as 2 to the power of 12 times 2. And another property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is going to equal 2 to the power of 12 to the power of 2. And I have this times 2 minus 1. So now I'm actually going to plug in the actual value of 2 to the power of 12, because 2 to the power of 12 is small enough where we know the exact value of it. So if you guys don't know what 2 to the power of 12 is, well, 2 to the power of 10, you should always remember this as 1024. So 2 to the power of 11 is going to be double of 1024, which is 2048. And 2 to the power of 12, which is the value we're looking for, is going to be double of 2048, which is 4096. So now I get 4096 squared times 2 minus 1. And now this is equal to, I'm going to simplify this, 4000 plus 96 squared times 2 minus 1. And the reason I'm doing this is because 4096 squared is really hard to calculate by itself. So if we change it to 4000 plus 96 squared, I can use the property a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, a is 4000 and b is 96. So this turns into 4000 squared plus 2 times 4000 times 96 plus 96 squared. And I have all of this minus 1. Oh, sorry, all of this times 2 minus 1. Now, 4000 squared is equal to 16 million. 2 times 4000 is 8000, and 8000 times 96 is equal to 768,000. And now I have this plus 96 squared, which is equal to 9,216. And all of this I have times 2 minus 1. So now I'm going to add all these up. So if I add all of these up in the parentheses, I get 16,777,216. So now I have this times 2 minus 1. So if I multiply this by 2, I get 33,554,432. And I have this minus 1, which is equal to 33,554,431. So this is my answer to this problem. Alright, so in this video, I'm going to be solving the problem 9 to the power of 900 minus 9 to the power of 901. So, to solve this, I'm going to first start by evaluating my terms. So we have 9 to the power of 900 and 9 to the power of 901. And these two terms are pretty similar, except that the exponent for 9 to the power of 900 is 1 less than the exponent for 9 to the power of 901. So the easiest way to solve this is to simplify this as much as we can. And a way to do that is to factor out a term. Well, 9 to the power of 900 is actually a factor of 9 to the power of 901. So all we have to do is rewrite 9 to the power of 901 as something times 9 to the power of 900. Well, we can use properties of exponents to do this. So I'm actually going to rewrite 9 to the power of 901 as 9 to the power of 900 plus 1. And now I can use the exponential property a to the power of m plus n is equal to a to the power of m times a to the power of n. So I get 9 to the power of 900 minus 9 to the power of 900 times 9 to the power of 1. So now from here, these two terms have the number 9 to the power of 900 in them. So I'm going to factor out 9 to the power of 900, which is what I said I was going to do at the beginning of the video. So now I get 9 to the power of 900 times 1 minus 9 to the power of 1. And this is equal to 9 to the power of 900 times 1 minus 9, because 9 to the power of 1 is the same thing as 9. Now 1 minus 9 is equal to negative 8. So I get 9 to the power of 900 times negative 8. Now from here, I said I was going to simplify this as much as possible. And we can't really get the exact value because 9 to the power of 900 is such a big number that we can't actually get the exact value for that. However, what we can get is the simplified value, and we're going to simplify it as much as possible. So I'm actually going to move this negative sign to the front. So I get negative 9 to the power of 900 times 8. And this gets me negative 3 squared to the power of 900 times 2 to the power of 3. We're simplifying these terms as much as possible. So I'm going to use a quick exponential property that states that a to the power of m to the power of n is equal to a to the power of m times n on 3 to the power of 2 to the power of 900. So I get negative 3 to the power of 1800 times 2 to the power of 3. So this is my final solution to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and even show this to any of your friends and family. That would support me a lot. I have a bunch of other videos similar to these on my channel, and if you're up for any challenges, I have a bunch of those, so please make sure to check them out. And thank you for watching. Bye. Alright, so in this video, I'm going to solve the equation x to the power of 12 minus 1 is equal to 0. So to solve this, I'm going to first rewrite this as x to the power of 6 to the power of 2 minus 1 squared is equal to 0. And the reason I'm doing this is so I can use the property a squared minus b squared is equal to a plus b times a minus b. So this turns into x to the power of 6 plus 1 times x to the power of 6 minus 1 is equal to 0. So this gives me two equations. I get x to the power of 6 plus 1 equals 0, and x to the power of 6 minus 1 equals 0. Now I'm going to do the same thing again. I'm going to rewrite x to the power of 6 minus 1 equals 0 as x to the power of 3 to the power of 2 minus 1 squared is equal to 0. So I can use this property again and get x to the power of 3 plus 1 times x to the power of 3 minus 1 is equal to 0. Now, for x to the power of 3 minus 1 equals 0, I'm going to rewrite this as x to the power of 3 minus 1 to the power of 3 equals 0, so I can use the property a to the power of 3 minus b to the power of 3 is equal to a minus b times a squared plus ab plus b squared. So let's turn it into a minus b times a squared plus a plus 1 is equal to 0. Sorry, this turned into x minus 1 times x squared plus x plus 1 is equal to 0, which gives me yet another two equations. So now I have x minus 1 equals 0 and x squared plus x plus 1 equals 0. So for x minus 1 equals 0, all I have to do is add 1 on both sides, and I get x is equal to 1. And for x squared plus x plus 1 equals 0, I can use the quadratic formula. So by using it, I get x is equal to negative 1 plus or minus the square root of 3i over 2. So these are two more solutions. And now we aren't done yet because we also have to solve these. So now I have x to the power of 3 plus 1 is equal to 0. And I'm going to subtract 1 on both sides, so I get x to the power of 3 is equal to negative 1, meaning x is also equal to negative 1. So this is another solution. Now for x to the power of 6 plus 1 equals 0, I'm going to again subtract 1 on both sides. So I get x to the power of 6 is equal to negative 1. And if I take the 6th root, I get x is equal to 6th root of negative 1, which is equal to negative 1 to the power of 1 over 6. So now, the 6th root of negative 1 is, say, we know that I is equal to the square root of negative 1, which is equal to negative 1 to the power of 1/2. So negative 1 to the power of 1 over 6 is the same thing as negative 1 to the power of 1/2 minus something. So now 1 over 6, or I should say 1/2 minus 1 over 6 is equal to 1 over 3. So 1 over 6 plus 1 over 3 is equal to 1/2. We know this, meaning we have negative 1 to the power of 1 over 6 and this plus, or sorry, 1 over 2 minus 1 over 3 is what we can rewrite 1 over 6 as. Now, this is the same thing as 1/2 plus negative 1 over 3. And if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So this is going to equal negative 1 to the power of 1/2 times negative 1 to the power of negative 1 over 3. Negative 1 to the power of 1/2 is the square root of negative 1, which is equal to I. So we get I times negative 1 to the power of negative 1 over 3, which is the same thing as 1 over negative 1 to the power of 1 over 3, which is equal to negative 1. So I get I times negative 1, which is equal to negative I, which is my final solution.